Welcome to an Achieving Science video. This video is all about rate of reaction and the effect of temperature. Before we begin, it's always worthwhile reminding ourselves of what happens in a chemical reaction. For a chemical reaction to take place, particles of reactants must collide with enough energy to react. In this video then, we're going to look at the effect of temperature upon rate of reaction. Let's have a look at an example. If we use particles A and B and see how these react, A and B represent elements. These particles are then going to react together to form a compound made up of A and B. So what happens then as temperature changes? Well, when particles are heated, they gain more energy, and therefore more particles have enough energy to react when they collide. This is called activation energy. Below this value, there will be no reaction. The definition of activation energy then is the minimum quantity of energy which the reactants must possess in order to undergo a specified chemical reaction. As well as having enough activation energy, the particles also move faster. Therefore, they collide more frequently. This therefore increases the number of successful collisions that take place. Therefore, in conclusion, we have found that as temperature increases, the rate of reaction also increases. As well as via the particle diagram, we can also show this via a graph. So let's have a look at this via a graph. So here we have the shape of the graph, a downwards curve, where we have temperature on the x-axis and on the y-axis the time for the reaction to finish. As you can see from the graph shows that as the temperature gets greater, i.e. increases, the reaction takes less and less time to finish, and therefore it shows that the reaction is getting quicker. Now let's look at this via rate of reaction. Rate of reaction can be calculated using an equation. So the equation that you need to use in order to calculate rate of reaction is rate of reaction equals the rate at which a reactant is used or a product is formed divided by time. Once we have calculated this rate of reaction, we can therefore now produce a reaction rate graph. Let's have a look at a reaction rate graph and an example. So here we have two graphs on one axis. We have a red line and a black line. On the x-axis we have time, and on the y-axis we have the amount of product that is formed. The red line shows the reaction happening at a low temperature, and the black line shows it happening at a higher temperature, both of which show the same reaction. So again, we can see initially the reaction is fastest. This is shown by a steep curve. As the reaction progresses, we can see the reaction gradually slows down, and the gradient reduces. Eventually, we'll reach the end of the reaction. This is shown by a flat line. This shows the reaction is finished. Therefore, in conclusion, this graph shows that the higher the temperature of the reactants, the quicker the reaction finishes.